Hey guys, in this video we are going to find out the performance parameters of the single phase full converter, right? So basically the speed of the separately excited motor DC motor is being controlled by what the single phase full converter. In the previous problem it was controlled by single phase semi converter. Here we are going to learn the full converter fed drive. Okay, the field circuit. So in this problem we are going to quite lengthy problem is there, but the thing is that line by line we have to read and write down the given things. That's all we have to do. Okay, so here what is given, let us try to understand. The field circuit is also controlled by the full converter, whatever is there. Okay, both circuits, two circuits will be there. One is the separately excited DC motor armature circuit as well as field circuit will be there, right? So the field circuit is also controlled by the full converter, and the field current is also set to maximum possible value. Okay, that is fine. The AC supply voltage to the armature and the field converter is one phase 440 volts 60 hertz. So this is from this it will start. Okay, so what is the main thing here? It is 440 and 60 hertz. So I'm going to write the given things is equal to what? The AC supply voltage is 440 volts. In the formulas, whatever we are going to use, it will be Vm. Okay, so Vm will be equal to root 2 times of Vs. So which is equal to root 2 times of 440, that you can write it as 622.25. So that part is that 60 hertz. Okay, we'll leave it that point. The armature resistance is given. So next quantity has come, armature resistance, and the field resistance is also given. So two quantities you can write it. One is armature resistance as well as the field resistance, 175 ohm. Done. Next part. And the motor voltage constant kV, which will be same as what? Kt, that is the torque constant also. So we will just write it over here. kV is equal to 1.4 volt per ampere radian per second. This is the unit. The armature current corresponding to the load demand is Ia. So Ia is also given. Then the viscous friction and the no-load losses are negligible. The inductance of this thing and so on is okay, fine, that is fine. Ripple free, okay till there. Okay. If the delay angle of the armature converter is alpha I, okay, so two things will be there. Here delay angle for the field converter also will be there, which is alpha F. Here they have given armature converter, that is nothing but alpha A. So we are going to denote it with alpha A, which is 60 degree. In degrees it is given, not in radians. Okay. And next, and the armature current is also given, which is specified over here itself, that is 45 ampere. Okay, so determine the first part of the question. It will start the torque developed by the motor TD. So we are going with the first part of the question, TD. Now what is the torque developed by the motor formula? We have to understand. It is nothing but Kt into If into Ia. Kt, as I said, it is same as kV. So instead of torque constant, I am going to write voltage constant. Both are same. So in this, if I want to find out TD, I need to know kV. So kV is given over here. You can observe. Ia is also given. Okay, fine. What about If? If is not given. But can I find out by using VF and RF? Yes, you can utilize VF and RF voltage to find out. But the thing is that RF is not given. VM and VS are different, right? RF is not given. VF is not given. How to find out VF? We have to go by the formula of semi single phase full converter drive of that formula. That is nothing but the average field voltage. That formula VF is equal to, for the full converter, is 2 Vm by pi into cos alpha F. This is the formula in order to find out VF. Now here, always remember, whenever you are finding VF, you have to go for the maximum field voltage and current. Therefore, for the maximum voltage and current, alpha F should be 0. That means this you have to consider, always remember, in order to calculate VF, you have to consider alpha F as 0 degree in order to get the maximum field voltage. It is not given in the question, but whenever you are calculating VF, You have to do like this. So alpha is 0. So because of what? To get maximum field voltage and current. Field V and current I. Okay. So Vf will become what? Cos 0. Cos 0 value is nothing but 1. So it will be 2 Vm by pi. So directly I have to substitute the values. It will be 2 into what is Vm value? Just now we have calculated, it is 622.25 divided by pi. So you will be getting the Vf value as 396.14 volts. Done. Vf is done. Now let us calculate the If value, right? If is equal to Vf by Rf. Rf is given in the question itself, which is 175. Vf 396.14 divided by 175 we have to do. We'll be getting If value as 2.26 amperes. If also we got. Now I have to substitute back in this Td to get the developed torque. So Td is equal to Kt or kV If into Ia. So kV value, as we know, it is given 1.4 into, it is given in the question, right? If value 2.26, just now calculated. Ia value we already have 45 amperes. It is given. So the answer will be 142.4 unit. Unit will be Newton meter, torque unit. Okay. So this is the answer for the first part of the question. Develop torque. This is you have to find. That means what? We have to apply the logic that we have to go by the formula as well. Whatever is the formula, we have to see whether it is given or not. If it is not given, you have to try other formulas to find out that values. Let us go for the second part of the question, which is to find out the speed. Now speed is basically, we are having one formula which relates the speed. It is nothing but Eg. We'll write first B part, Eg. So what is the Eg formula? Eg formula is nothing but kV into omega into If. This is the Eg formula. From this I can find out omega value, which is the speed. Omega is equal to Eg divided by kV into If. Simple. Now here one problem is there. Eg value is not given. Back EMF value is not given. kV is given. If we just found out. So that is also given. Eg we have to find out. How to find Eg? Eg again separate formula is not there. Anyways, this is only the formula for Eg, right? Separate formula is not there, but we can relate it to what, which formula, which is the other formula, VA formula we can relate. So VA we are having Eg plus IARA or IARA plus Eg, same thing. From this, can I find out Eg? Yes, it is possible. So from this, Eg becomes VA minus IARA, right? Just shifting to that side. But again, in order to find Eg, then again substitute back here. Substitute back here in order to find out Eg. Omega. VA whether it is given in the question? No, it is not given. IA whether it is given? Yes, it is given. R is also. VA again I have to find. Okay, we have to go back to the single phase full converter average armature voltage. We are having the formula 2 Vm. This is for the full converter. 2 Vm by pi cos alpha A. Now here remember, in order to calculate this we need alpha A value, which is given in the question, as we have written over here also. Alpha A is 60 degree. So degrees only you have to consider. 2 into Vm 622.25 divided by pi into cos 60 degrees. Okay, in degree only we have to consider. We'll be getting the value as 198.07 volts. We got VA. Now I have to substitute this in this to get Eg. So Eg will be equal to VA minus IARA. So what is EVA 198.07 minus IA value is 45 amperes. RA resistance is 0.25. So I'm going to write 0.25. So after solving this, you will be getting Eg value as 186.82 volts. That part is also done. After finding Eg, now we have to substitute back in this formula to find out what? Omega. So omega is equal to Eg divided by kV into If. Eg value we got 186.82 divided by kV value is 1.4. IF we already calculated 2.26. Here you can see we calculated IF value 2.26. Okay. KV is given in the question. After calculating, you will be getting the answer as 59.05. So whatever the answer you are getting, it will be in what radian per second. Remember this. When you are calculating the speed, you will be getting the answer in radian per second. If you want, you can convert it into what RPM. Okay, revolution per minute. How to convert it to RPM? See, I'll tell you one thing here. From radian per second to RPM, what you have to do? You have to just multiply whatever the radian per second. You have to just multiply whatever radian per second is there into 30 by pi. Okay. If you want to convert RPM to radian per second, you have to just take the reciprocal. That means RPM you take, you have to just multiply by pi by 30. These things you remember. Okay. So here we have to convert into RPM. Therefore 30 by pi you have to multiply. So omega value you will be getting it as approximately 563.84. So approximately you can write it as 564 RPM. Okay. So I've just multiplied into 30 by pi in order to convert. If you don't want to convert, okay, it can be in radian per second only. It is fine. But generally RPM only we will mention it. Okay, that's why you have to convert. Let us go for the C part. C part is nothing but the input power factor of the drive we have to find out. Again, previous problem we have done, but it was for what? The semi converter. But here it is full converter for drive. So here some calculation is there. One direct formula is also there. You might have studied for the not with related to separately excited DC motor, but instead of that you might have studied the direct formula which we have used for single phase full converter, only the full converter. That formula was basically the input power factor was given by 2 root 2 divided by pi into cos alpha. This was the direct formula which you have studied in the single phase full converter. Okay, but here it is the full converter drive. This drive is for the what separately excited DC motor in order to control the speed. Okay, so here anyways we can use this formula also, directly substitute alpha I. Alpha is given in the question 60 degree. So if you substitute 60 degree, you'll be getting the PF value as what? Cos 60 into 2 root 2 by pi. You'll be getting 0.45. Power factor is 0.45 you'll be getting. Okay, that is fine. But anyways, we'll try to analyze using other method also. So what is the other method we are going to do? Anyways, if you want, you can stop it here itself. But the other method is there. So we are going to assume that this is a lossless single phase full converter, and the input power factor. Sorry. See what you have to find out. See input power factor. In order to find out, you have to just take the PI by VI rating. That's what you are going to take. So how to find out PI? The input power. Input power is given by VAIA plus VFIF. Okay. So here all the values is given. VA value is 198.06. We just calculated here, right? 198.06. Then IA value we know 45 amperes. VF also we calculated in the starting, which is 396.13. You can see over here VF value 396.13, and IF value anyways we have calculated 2.26. This is the input power from the supply. So we will be getting the answer as 9.8 kilowatts, or we can say directly 9807.95 watts. Then VI we have to calculate, that's a volt. So we are going to find out VA, the denominator part. It is given by VS into IS. VS we already know, it is 440. Supply AC supply input is given as 440. That is fine, but IS is the most complicated thing. In order to find out IS, it is basically the I'll just write over here. Is is equal to square root of ISA square plus ISF square. This is what we are going to do. Now let me just tell you what is this complicated thing. IS is basically the effective RMS supply current. ISA RMS value of the current, RMS value, and it is equal to directly equal to IA. So IA is basically 45 amperes given in the question. So it is equal to 45 ampere itself. Now what is ISF? ISF is the RMS value of input current of the field converter. This is for the armature converter. Okay, so that you have to do. So what all values we are having? So how to find ISF square? ISF square is nothing but the IF only. So this particular part is nothing but IF. Okay, so you can simplify and write it as IS. Whatever you are going to find out, it is nothing but square root of IA square plus IF square. So that is equal to 45 square plus IF. IF we found out, which is 2.26 square. So you will be getting the answer as 45.06 ampere. Okay, IS we got. Now substitute back here in order to find out the VI rating. So it is 440 into 45.06. You will be getting 19,826.4. Now we are going to find out the power factor. It is equal to input power from the supply divided by the VI rating. It is 9,800. How much we got? 7.95 divided by 19,826.4. So you will be getting approximately 0.49. Okay, so power factor we got here. So there will be slight difference between this and this. This power factor we have directly, it is directly dependent on the alpha A value. So if alpha A is 60, it will be depending on that because other values are constant. But here this thing is that input power factor, whatever, it depends on the input power from the supply as well as the VI rating. Okay, a volt ampere rating. So that is so that's why the variation will be there. So if you don't want to do this entire steps, you can limit your answer to this for the C part in order to find out the input power factor directly by putting the single phase full converter power input power factor formula. This is the formula for that. Okay, so I hope you understood this part. So this is the answer.